Create optical lighting and illumination and laser systems with OpticStudio, the industry-leading optical design software from ZMax.
Hello everyone, and welcome to today's webinar. Today we'll be talking about the new features, additions and upgrades that we've made to OpticStudio, and it's now in version 17.5. My name is Thomas Pickering. I'll be your host for today, but first I would like to hand over to one of our senior members of the engineering team, Michael Chang. He'll be introducing the new contrast loss map analysis, which is a feature that lets you visualize how the MTF is degrading across the pupil.
Hi, welcome to the webinar today. Here I'm going to introduce one of the great new features released in OpticStudio 17.5, the contrast loss map. The contrast loss map is a tool that displays contrast loss across the pupil at a specific spatial frequency, field, and wavelengths. The most important use of contrast loss map is it indicates which region of the beam in the pupil coordinate contributes most to a poor MTF. As we know, MTF is one of the biggest requirements of most of the optical imaging science. If you remember, when OpticStudio 17 is released, we have introduced the contrast optimization, which is for optimizing MTF of the system. Now, in OpticStudio 17.5, we introduced the contrast loss map, which is used to analyze. We can analyze the MTF with contrast loss map and improve MTF with contrast optimization. So, where can we find this tool? As you can see in the slides, the contrast loss map can be found in two places, under the wavefront button and under the MTF button. Let's see how it looks like in OpticStudio. As you can see here, it's under wavefront and under MTF. These two places actually will reflect where the contrast loss map comes from and where the contrast loss map is designed for. Now let's see how it's derived from the wavefront. Before we start explaining the contrast loss, let me first have a quick review about how MTF can be calculated by autocorrelation of the pupil function. First, pupil function is a complex function on exit pupil, which can be determined by tracing rays from the object to the image, and then tracing back to exit pupil, as you can see on the slides. And the first part of the exponential is known as the wavefront. Now we have a definition of the pupil function. In this page, we can find the important equation behind the concept of the contrast loss map. As you can see in the equation, MTF at frequency psi x and psi y can be calculated as autocorrelation of the pupil function. The P here is the pupil function as mentioned before, and P star is the complex conjugate of the pupil function. Psi x and psi y is the spatial frequency in x and y direction, and the n is the working F number. So given this equation here, we just got a very important insight to the MTF. If we define delta as you can see here, we can say for a given spatial frequency, like the psi x and psi y here, the MTF value can be calculated by multiply P and the P star, where the P star is shifted by delta, and then integrate the overlap area and take modulus, as you can see in the schematic and the equation. Given that the MTF can be calculated from the autocorrelation of the pupil function, here we can define the phase difference and the contrast loss. The phase difference are defined here. For any pupil coordinate, px and py, we can always trace two rays. The two rays are launched from same field and the same wavelength, and are separated by delta in pupil coordinates. For sagittal, they are separated in x direction in a pupil, and for tangential, they are separated in y direction. The contrast loss is then defined as here: 0.5 times 1 minus cosine phase difference. The value of contrast loss is always between 1 and 0. Phi 1 and phi 2 in the equation are optical phase difference of the ray, and the delta is the pupil shift. It's related to spatial frequency as we talked in previous slide. So given all this definition, here's the most important conclusion we get from the autocorrelation theory. If the contrast loss or phase difference over all the pupil are 0, we can get the best possible NTF for the specified spatial frequency. Okay, so let's go back to the contrast loss map. Contrast loss map is a tool that can visualize contrast loss over the pupil coordinate, as we mentioned before. For each sampled point on the pupil, the contrast loss is represented by circles. The larger the contrast loss is, the larger the circle is. In the setting as you can see here, there are sampling, frequency, wavelength, field, normalize, and show OPD. Since contrast loss map is actually calculated from wavefront map, we will not be surprised that we can choose wavelength and the field, just like in wavefront map. Now let's have a quick look on these two settings, sampling and frequency. By default, OpticStudio will use 13 by 13 grid to sample the pupil. If we increase the sampling, we can see more details. For example, if I increase it to 29, you can see there are actually more details in this region. That is not obvious when the sampling is low. And here is the frequency. This is the most important option in contrast loss map. Every contrast loss map are all related to a specific spatial frequency of NTF. This makes it possible to analyze which region in the pupil coordinate contributes to the low NTF at a specific frequency. For example, if I change the frequency to 16, as you can see, this region in the pupil coordinates contributes much in decreasing the NTF when the frequency is 60. And for NTF at frequency 30, this region is not a big problem. Now let's look at the option normalize. Sometimes when the optical system is near perfect, or when we choose a low spatial frequency in the contrast loss map, it is possible that the maximum contrast loss over the pupil are too small to be read. In this case, we can check the normalize to scale all circles so that the maximum value in a plot is displayed at the maximum allowed circle size. When normalize is checked, you can also see plot scale displayed in the command area here to tell you the maximum contrast loss value in the MacLeod. So when we check normalize in contrast loss map, all the circles will be rescaled so that we can check details in the map. However, if you see all the circles are all small in the contrast loss map, it could be that the system is already near diffraction limited. And if it is the case, there's only very little for NTF to improve, and it's meaningless to scale the small circles to analyze. For this reason, in the contrast loss map, we always display the NTF and the diffraction limited NTF value. By checking this value, we can easily know how much we can still improve the NTF for the system. The final option in the settings we will introduce is the Show OPD. As we know, the contrast loss in the map is caused by the non-zero phase difference for the sample point. And the phase difference for the sample point can actually be positive or negative. If now we want to know the sign of the phase difference, the only way is to check the waveform map. And this is what Show OPD can help. If we check Show OPD in contrast loss map, the waveform information for each sample point can be displayed by showing an indicator in a circle, as you can see here. The indicator is pointed to positive x when the waveform is 0, and it will rotate clockwise when the waveform increases, and it will rotate counterclockwise when the waveform decreases. This option is mainly useful when peak-to-valley waveforms are only a few wavelengths. For example, in this contrast loss map, as we can see in tangential plot, the contrast loss are large in top and bottom regions in the pupil. And if we look at the indicators in a circle from center of the pupil to the edge, we can see the indicators rotate counterclockwise. So we know the waveform decreases in this direction and is higher at the top and the bottom edge. And here is the waveform map of this system. We can easily verify that waveform is definitely decreasing at the top, bottom, and the bottom regions in the pupil. Thank you for listening to the introduction of the contrast loss map. If you're interested in more information, details, and the example on how to use it, here are more information for you. Thank you.
Thank you very much, Michael. I'll be introducing you to the other additions to OpticStudio 17.5. The first improvement that we made was to the field data editor. And the field data editor is an addition to OpticStudio 17. And since then, we've added some more functionality just to make it easier to manage large sets of field points more easily when you design, for example, wide-angle systems. To show you these additions, I'm just going to switch over to OpticStudio. So let me go here. So first of all, the field data editor, you can find them. You can find it either under the Setup tab here in the field data editor, under the Editors section, or simply by expanding the fields in the System Explorer and clicking this button here. I've already got one open, and as you can see, so this is, we currently have a system set up with 3 field points. The additions that we've made to the field data editor is, first of all, we've added a configuration switch here at the top. This is similar to, for example, the lens data editor, but it's also the same in every other editor that we have. Simply makes it easier to switch between various configurations and to see how the field points are defined in each configuration. The next addition that we made was is a little help to make it easier turning on and off the an individual field points. And to do so, all you have to do is expand the field properties for a given field. And in, let me make this a little bit smaller here, and in the current field section here, you can find a little ignored box now. So if I tick this, you can see now that the line in the field data editor is grayed out, and this makes that the field point is now ignored. So you don't have to delete and insert again, it's simply turn on and off with this little tick box here. And the final addition is we've added pickup solves in all the columns that are, so all the vignetting columns here, so all the vignetting factors, including the vignetting angle, as well as the weight column. So what this means is for example here, if I want everything that's off axis with a half weight, and say I want to make this change, you know, more easily, if I want to make an additional change afterwards, I can say pick up from field 2. And now if I change field number 2 back to 1, field 3 picks up the value. Another addition to the field data editor is the field plot. And what the field plot does, it ensures you that the field of view that you're modeling is accurately sampled, and it just helps you visualize this. And this is particularly helpful when you design freeform systems. So to do this, I'm just going to pop the field data editor out, so it's made a little bit bigger. You can find the field plot here on the right. It's currently minimized, so to make it bigger, you can simply press this little arrow button here, and the field data editor pops out. And it's, as I said, it's simply a visualization of where your current field points are. As you can see here, we've currently 3 field points. The middle one seems slightly highlighted. It's because it sits at 14 degrees angle, and it's the 3rd field point at 14 degrees. So it's the currently active and highlighted field point, and that's also active and highlighted here on the field plot. So if I move in between the lines, you can see that the active sort of like highlight switches on the field plot too. As you know that we can, since OpticStudio 17, we can have more than 12 field points. And this is also displayed in the field plot itself. So if let's make a few more. So I'm gonna do a grid between, say, let's do 25 field points. Let's go up to 15 and 10 and apply. And you can see now is the first 12 field points are in a green, and they're also in a green here on my field plot. And then the next, say 13 field points are in a yellow, and they're also on the yellow here on the plot. As I mentioned, this helps you a lot to see how your field of view is sampled, and yeah, this just helps you if you design systems that need to have a high sampling of the field itself. If you don't need to see this all the time, you can simply collapse it by clicking the close button. The next sort of simplification we made in the user interface is with the optimization wizard. So with the optimization wizard, you have a lot of options, and we wanted to make it easier for you to build a merit function that's correct the first time. So to show you what I mean, I'm just going to go into the optimization tab and open the merit function editor. Again, I'm going to move it out a little bit, and up, and then make it a bit bigger, and then let's open the field data, so the optimization wizard, and you can see that the user interface has changed a little bit. So first, so the user, or the workflow with the optimization wizard is to start at the top left and then move to the right, and then finally go to the bottom box here. So in the top left corner, we've got the optimization function, and we now have in the criterion drop-down menu here, we've got 4 criteria available. And you can see it starts with the wavefront, and wavefront is the criterion that measures the aberration in waves. And that's the same as we had in 17 and previous versions. The next criterion is contrast. Michael already talked about the contrast function, and the contrast is used to optimize the MTF, and that's been introduced in OpticStudio 17. The next one down is spot, and what spot does, it computes both the X and the Y extent of the transverse ray aberrations in the image space. And then finally, we've got angular. And what angular does is it computes the X and Y extent in the angular aberrations in image space. Both spot and angular consider the X and Y components separately, and they're separately considered but are both optimized together. but the positive aspect of this is that the sign of the aberrations are retained, and this yields, this makes the optimization results a whole lot better. Let me select contrast here, and you can see that the next line here is spatial frequency. This is where you set the spatial frequency up to which you want the MTF to be optimized, and you can even give a different weighting to the sagittal and the tangential contrast function. And then, as you're already used to, the same goes for spot and angular, where you set the X and Y weight for the spot size if you don't want a circular spot size. The other sections stay the same in the wizard. So we have the pupil integration. We simply moved it a little bit to make it more obvious that this would be the next section to set. The boundary values being still optional, and then finally some general settings, like for example, the overall weight for your default merit function or the configurations and fields. So the next additions that we have is we have changed a little bit how false color plots and analyses are displayed. So I have one open here. It's a PSF, and you can see here, this is our normal false color depiction of a PSF, and the color spectrum that we use is, we call it, just to show you, we call it spectrum, and spectrum is a color palette that is based on the JET color palette or color map. This color map is widely used. However, it has some drawbacks. For example, it's not particularly well visible for people with certain types of color blindness, or it also doesn't print very well for a grayscale printer. So therefore, we've added some false color maps. So one's called Viridis, the other one's called Magma. As I showed you, they are to be found in the project preferences under the graphics tab. Yeah, so under false color here, you can choose between the three false color settings. And the first one, as I said, was Viridis, and Viridis makes it so that high values are given in a very bright yellow and low values are given in a very dark blue. This makes it much easier for, as I mentioned already, for the applications to see a lot better contrast. And the same goes for the settings of Magma, where the high intensity is in a sort of like whitish yellow, and the low intensity is in a dark blackish blue, and it goes via shades of purple. Let me rearrange this a little bit. With OpticStudio 17.5, you can now run macros that you programmed in our Zemax programming language. You can now run them from the command line. So if you have any standalone macros that you want to run without having to open the user interface yourself, you can now do so, and simply with a command line. And I'm going to use the Windows command line. I've got one open here already. So you need to go into your wherever Zemax OpticStudio is installed, and then simply run a command line like this. The first line, so you start OpticStudio, and then the next few arguments are, the first one is the actual macro that you want to run. And then the next few arguments are variables that you may want to pass on into the macro itself. So I'm going to pass on a variable called surface with a value of 1, and I'm passing on a variable called output file with a value of basically the path and the file name where the output file needs to go. And if I hit enter, OpticStudio starts itself. Yeah, OpticStudio starts itself. I'm sorry for the pop-ups. It starts itself, and it runs the macro, and then as soon as it's done with running the macro, it closes down again. Yeah, so you just see a quick run through of the macro itself. It closes down, and then when you go to the location of where the file sits, yeah, you can see we've just created this. You can open it up, and yeah, basically run a macro that writes out that we run from the command line. Okay. The next two additions are all about our libraries. As you know, we constantly make updates to our libraries, but I just wanted to highlight a couple of bigger additions. The first one is that we've added a lot of various codings from a coding simulation company called Essential MacLeod. And these codings are based on thin film codings, real thin film codings, rather than approximations or ideal definitions. So these new codings can be found in the coding files itself. So to find the coding file, you go to Libraries. It's in the coding tools, and we just look at the coding file. And let's pull that one out. And once you move a bit further down in your coding file, you can see that you've now got a whole section that has very common examples of Essential MacLeod codings. We have a very good knowledge base article on our website, on our customers portal, and you can find the link here. And if you go through these codings, there are various applications. So for example, there's anti-reflection codings, cold mirror codings, beam splitters, as well as enhanced reflectivity and near infrared. So there's several codings, and you can see that they are made of thin films rather than ideal approximations. Okay. And then finally, the last addition that we made was we have, in order for you to get started on new optical designs, we've added some more sample files, and we've taken these example files from a book called Perspectives on Modern Optics and Imaging, which is a new book written by Ronian Siew. And we've added these to the installer. So you can find these new sample files simply by going File, Open, and you go to your sample files under Design Applications. Expand this a little bit. Under Design Applications. And you find here Perspectives on Modern Optics and Imaging. And when you double click this, you can find 14 new sample files that correspond to the book you wrote. And you can just go through them and either study them if you want to study some more modern optical systems, or use them as starting points for your design. Thank you very much for attending this webinar. So OpticStudio 17 is available for download on our website. It was released on November 16th. So if you haven't got it yet, go ahead and download it. And if you have any questions, you can submit them now via the text box in the control panel. Simply type them out and I'll address them as good as I can. If you have any further questions after the end of this webinar, please send your questions and as well as comments to our support team and the support@zemax.com, and we'll do our best to answer them and help you. Just have one question coming in about have there been any additions to any other catalogs? Yes, there have. As usual, we always make sure that we add the latest catalogs from our vendors, and we've added material catalogs from CDGM and Umicore, so catalog updates from those vendors, as well as a new stock lens catalog from Edmund Optics, and also a couple of more radiant source models to the radiant source model catalogs. There was one question coming in from how many fields can you visualize in the field data editor? So in the field plot that comes with the field data editor, you are able to visualize all the field points that they are. I haven't really tried this. I mean, let's have a go and see if we can do this. And let's open the field data editor again. So as I mentioned, at the moment, I've got 25 open. Let's open the field plot and say I want to, I don't know, let's do 15 by 15. Yeah, so you can see that however many field points you have, you can sample them as accurately as possible, and they're visualized on your field plot. Sorry about that. There's one question coming in if there is a limitation on only visualizing the first 12 field points. So if a grouped visualization is only available for the first group of 12 field points, and that's correct. If you would like to individually visualize the other field points, then you can do so individually. So say you can visualize field points 1 till 12 together, and then all field points individually. We're still working on developing a sensible and clear way of visualizing other, more field points. And if you have any feedback on this, please send us an email and let us know how you would like this to see and how you think we should visualize this. We appreciate any input. I have a question from another question from you about what the significance of the green and yellow on the field plot is. I'm not sure I mentioned this previously. The green on the field plot corresponds to, sorry, I don't know if you, so the green on the field plot corresponds to green lines in here. As I mentioned, you've got here the active field dot here, and it's a little bit difficult to see because there's quite a lot of field points. So the active field point here is this corner field plot. And if I move down in my fields, so say now my active field point is field number 3, and it's this corner point here. And if I'm choosing an active field point to be field number 16, which is one of the yellow field points, it's one of these here. So yellow dot here means yellow line in my field data editor. One question came in about how to best set the spatial frequency in contrast optimization with regards to the merit function. This totally depends on the application. The benefit of using a contrast optimization function is an MTF optimization only addresses an optimization with regards to a single spatial frequency. What the contrast optimization does, it actually makes it very, very good to trade off the contrast in a say, if you want to have it, if you want to optimize a contrast up to say 30 cycles per millimeter, you can take a good contrast at 50 and move it so to push it into a good contrast into 30. So it's actually a really nice trade-off, and it makes a much more optimized system than if you just address the MTF itself. But which MTF or contrast frequency you choose is depending on the system itself. I have one question on some mathematical functionality with regards to the contrast function itself. This was part of Michael's presentation. I'll feed this question forward to Michael and I'll let him answer this, and we'll get in touch with whoever answered this. Thank you very much. Any other questions that you have or concerns about OpticStudio 17.5, please email us at support@zemax.com, and we'll try to help you as good as we can. If there are no more questions, again, I'm saying thank you for attending our webinar, and I'll hope to see all of you very soon for another one of these. Thank you very much.